Hello, how are you? Welcome to my silent disco. How are we going? Can you all hear me all right? It's the weirdness of these headphones. I've only done this once before. It makes me feel like a DJ, like a Calvin Harris or something up here. It's amazing. So we're going to be talking today about containerizing .NET apps with Amazon EKS. And at the end, we're going to be talking a little bit about AWS Fargate as well. How many people in the room here are .NET developers? Well, then you're in the right place, which is good. I'm also a .NET developer. I've been a developer now for quite some time, nearly 20 years. And this is what we're going to be talking about roughly today. How many people are using containers today in their .NET development? Okay, about half of you. So we're going to be talking a little bit about containers and what they are. A very, very brief overview of what Docker is, just in case there are people which just have not used it or seen it before. We're going to be talking about what the benefits of containerizing .NET are and why you would want to do it in the first place. We're going to look a little bit about some of the products which are around, or the services which are around this ecosystem. In particular, we'll look at ECR, which is a registry for your containers, and we'll show you how you can integrate with that. Then finally, we'll look at EKS and using Kubernetes, our managed Kubernetes service, and how you can deploy .NET applications to that, and that being .NET older versions of .NET and also .NET Core applications to Kubernetes. I'll also briefly touch on ECS, which is an alternative way of deploying containers on AWS, but that will be very light. I won't be talking too much in depth about that. And then finally, we talk about Fargate and the new cool things that you can do with Fargate on both ECS and now EKS as well, as of this morning. So this is an important slide, possibly the most important slide for me personally in the whole deck. I need to actually be in the picture. Look, we've got this is called my inception slide, and this is me in front of a slide, in front of a slide, in front of a slide, in front of a slide. You'll see that picture goes on and on and on and on and on. It's actually 40 levels deep. That slide, so it's quite important. I'm trying to get to a level 100 with that. It's nothing to do with .NET or containers. It's just a personal mission. I've been a developer since I was 16 years old. I started as a web developer, really, doing CGI bin and Perl. Then moved on to PHP, and then someone showed me the door to Microsoft, and I started doing ASP. And then I went to 4guysforroller.com and learned .NET from that. And I've been developing in the .NET space for over 20 years. I've previously worked as a software engineer at Microsoft for 8 years, and then I had a brief stint in Oracle, and then I've just joined Amazon Web Services about a year and a half ago now. And my whole job at AWS is talking about .NET. So .NET on AWS. So all the different ways that you could use .NET on AWS, that's my job. Talking about that, showing people how to do that sort of stuff. So whether that be serverless, whether it be containers, whether it's Elastic Beanstalk or whatever. So we'll be talking a lot about containers in this session, but it's just to let you know that .NET is AWS is a very good place for .NET. Like lots of our customers are using .NET and using it interestingly in different ways, from the container platforms to serverless platforms, all the way through just to standard EC2 instances. So let's just talk a little bit about containers, in case you haven't used them before. The main benefit is that containers are sharing a kernel. So rather than a traditional VM where you have the hypervisor, where you've got the guest OSs and the virtual machines, which are very heavy, all of which have their own kernel, and they go through to the server, to the underlying operating system, to the underlying hardware. With containers, we have this ability to share the kernel, and so we are able to have much smaller blocks or much smaller things or objects that we can initialize. And so they're much faster to start generally than virtual machines. And they're very powerful because one of the things which is being really popular about containers is the fact that once you've built a container and you've created a container, that container is kind of the same wherever you put it. If you take that container, you build that application inside of a container, you can move it to another machine and guarantee pretty much it's going to behave exactly the same on the other machine as it does on your machine. And that kind of dev workflow of building a container, testing that container, knowing that that's the actual thing, that object won't change, there's no dependencies outside of the operating system which is relying on. Everything which it needs is inside that container and wrapped in that container. Makes it extraordinarily powerful for moving these things about, and lots of people are building their application workflows around these. So CI/CD systems are heavily invested and built around containers. So one of the reasons why these are becoming extremely popular is because you have this single, well, I think it's because you get this single package, this single artifact that you can distribute. And that makes it easy to send it to other teammates, it's easy to share online, and so forth. And this became very popular in the open source world. It certainly became very popular in the Linux world. But .NET was sort of slower to catch on. There was a few things which are happening in .NET. Obviously, we have .NET Core, which is a framework which actually could run on Linux. And so we were able to sort of containerize that. But then when we think about older legacy applications or Windows-based applications, containerizing them has been a challenge. And it's only recently, in the last couple of years, that Microsoft have changed their server architecture to sort of match some of the stuff that Linux is doing. So it makes containers a useful thing, not only for Linux-based .NET Core applications, but also for full-fat framework .NET applications. So it's a very lightweight virtualization platform. Pretty much everyone which is doing containers is using Docker. There's other containerization ways of building containers, but generally speaking, in my personal career, I've never built anything but a Docker container, so I don't really know anything about the other container platforms. It's become extraordinarily popular as a standard way of building containers, but containers are, you know, in Linux at least, a fundamental part of the operating system. And it's actually, there's a brilliant a YouTube video about how to build a container in Go from scratch without Docker, just purely building it from the basic fundamentals of what Linux has. And actually, it's not as difficult to build a container as you might think. But the thing is that Docker's come out and it's become battle hardened. You know, there's lots of security features and so forth built into Docker, and it's become somewhat of a standard in the industry. Although there's other things which are available. It's an open source platform. It's an Apache 2 license, so you can use it inside of any kind of application, and it's making things a lot simpler. The way you can think about a container, or the image, the Docker image which makes up a container, is I think of it as like layers. So you're building up these layers to create a container. It's a union file system which combines to create an image, which ends up being our Docker image. It's not important to understand this too much when you're starting out, but it's as you get deeper and understand a little bit more about containers, it's important to understand how they fit together, because you can start optimizing for how you build containers and how you pass containers and images and layers around. To create a Docker container, you start with a thing called a Docker file. So a Docker file is an instruction set, and each line in a Docker file is effectively a creation of a layer inside of a Docker container. So here I've got 4 commands. From is my base layer from Microsoft Windows Server Core. And then run add Windows Feature Web Server to that container. That next step affects the previous layer, so we're basically creating 2 layers. And then run add Windows Features.NET Framework, that would add a 3rd layer. And finally, it copies my application to another place. So there's 4 different instructions inside of that Docker file. It will create a Docker image which has 4 layers. The Docker layer, the first part of that is the, you know, here we're using Windows Server Core. It's a big container image, 7 gigs in that instance. That is created into 1 layer or file system. Then the next command's run, and it's kind of like a diff of the previous file system. So you end up with another layer, which is just a diff, the change of the files. And then you have another layer on top of that, and another layer on top of that. And the reason why these images are built up like that, if you have on a platform, maybe you're building 2 Docker images, and both of them inherit from the Windows Server Core layer, you don't need to have that layer twice, even though it's referenced in 2 different containers. Docker's clever enough to store that layer once and then use it in multiple containers. And what that means is that if you're using containers on a server where some of your containers are sharing lots of different layers, then it means that they take actually less footprint on the server in physical storage, because they're sharing these layers. So Docker has a really intelligent way of sharing all of the different layers across Docker images. And what you end up, there's a little bit stuff surrounding the additional elements of your file system. There's a read-write layer inside of a container. And then fundamentally, that's your Docker container, which you're able to then go and deploy or do something with. So this is maybe a better example of a Docker file. we've got a few more steps, but this is also MultiBuild, a MultiBuild file. And you'll notice that there's two from statements. There's one at the top, and there's one a little bit further on down. This is a relatively new feature in Docker, as of a couple of years ago. The concept of multi-stage is that you inherit from a base layer, we then do some stuff in that container, we build our container up, and then we output the files from that container and create a fresh container in the second portion. And the reason we do this multi-stage is because when you're building an image, you might want to be building, you might need this SDK base image. You might need some SDK files to actually build your project. But by the time you actually want to publish your container, you probably don't want all the SDK stuff in the container. You just want like the svelte version of Windows with the .NET runtime rather than the SDK. And so that's what we're doing here, is we're taking two different base layers and we're using one as almost a build doc container, and then we take the output files and pass them into the second container, which is what's going to be actually the container that we pass out, the thing that we go and store in our registry. Multi-stage build is relatively new, but people have been doing this before it was supported directly in Docker. There was other systems which was able to do this sort of concept of building containers and then building containers on top of those containers or the outputs of those containers. And what you'll note is that the bottom image there, it's got a base layer, it copies the working directory, creates a working directory. We copy the build output to that application folder. We expose port 80. And then our entry point to our application is .NET executing a DLL. So this is a .NET core application, but ultimately the thing that happens when that Docker container starts up is it's running .NET against a DLL. So quite straightforward sort of Docker file, and that's but a better example of perhaps how you would actually use a Docker file in the real world. So the kind of workflow is, we would take a base image. So that from statement is taking a base image from somewhere. Usually that comes from somewhere like Docker Hub, which we call a container registry. And this is a store of containers. Now, when you say from, you're basically taking it from another container. So from Microsoft.NET 2.1 SDK Nano Server, that's a container which lives somewhere in some registry. So you're always building containers on top of containers. And you're using another person's container as the base layer. Sometimes you'll use a really svelte Alpine version of Linux as your base layer. Sometimes you'll be using a fully fledged version of Windows as your base layer. It really depends on what kind of container you're building, what you need to be able to do with it, and what kind of applications you need to run. Obviously, the bigger the base layer, the bigger the resultant image, and the bigger the resulting container. And one of the common problems with building .NET in containers is that many of the, at least legacy frameworks, haven't been built for the world of containers, so it means that you end up with very, very large containers, which can be a problem because they're not really, when you have like a 40 gig Docker container, it's difficult to move, it's difficult to copy over the network, it's difficult to use. So you will find in the container world, you can pretty much containerize anything. You containerize legacy applications, you could containerize Oracle databases if you want. But you shouldn't. You shouldn't probably. The worst case is I've seen a customer which had containerized an 80 gig Oracle database inside of a single container. It's probably not a great idea to do that. Friends don't let friends put databases inside of containers, in my opinion. So we pull the base image, we build the image from the Docker file, we inspect the container, we attach a volume to the container because obviously containers don't have or necessarily have any storage which is permanent. So you might want to attach some actual permanent storage to that container because however you're managing or running or orchestrating your containers, if they fall over, you don't want to lose all of the data which is there. So we have this concept of attaching a volume or attaching a file system to your container. And then we would run our container. And if we were in dev working in our dev modes, we'd probably just run it in Docker on our desktops. But if we're going to be putting it into production, we might use any one of a number of container orchestrators. And AWS has more than one container orchestrator. So once you have a Docker container, you can either run it in EKS or ECS, the Elastic Container Service. The reasons why you would do that vary. And generally we find that customers choose one and stick with that and prefer that one, and then they'll carry on that journey along that way. But they both do very similar things. So when I talk about what EKS or the Kubernetes service does, you'll find that there's versions or ways of doing that same things inside of ECS as well. So let's talk about containerizing .NET applications specifically. Now, the reasons why you might want to containerize is the idea of having better it's the same reasons why any platform would want to use containers. There's better resource utilization. We have the ability to have a consistency of deployment. As soon as you've built a container, it's kind of unchangeable, it's immutable. So you know that nothing's been introduced to that container between dev, test, and prod. There's no more, it works on my machine. It doesn't work on the actual production server. So there's a much more consistent way of deploying an artifact. And because the way that we can take these containers and we can use an orchestrator like Kubernetes or ECS, it becomes far easier to scale these than it is to scale virtual machines. Not only is it easier to orchestrate the scaling, they're also quicker to scale, and you can get more containers on physical servers. So it's got like the ability to squeeze more containers on a single server than you probably would find if you were trying to do that all with just virtual machines. Now, if you're building .NET, you're probably building one of two types of .NET. You're either building .NET Core or you're building .NET Windows. How many people are building .NET Windows? And how many people are building .NET Core? Still, like .NET Core is actually ahead there, which is cool. But it means that there's still quite a lot of people which are using .NET and legacy applications. And there's lots of reasons why that is. Sometimes it's the case that you have applications which you just can't port to .NET Core. And I've certainly found that in my career. There's lots of still, even in .NET 3, there's still lots of namespaces that just can't be ported, or you can't have an equivalent in .NET Core. Or maybe you've got a third-party DLL which you just can't port to .NET Core yet. So we always live in a world where there's going to be two project types. There's going to be people which are building in .NET for Windows and .NET Core. Now, .NET Core can run on two operating systems. It can either run on Windows or it can run on Linux. Now, .NET Core that runs on Linux, as soon as it's packaged into a Docker container, it's indistinguishable from a Linux container because it is a Linux container. So whenever you see any sort of framework which talks about containers or supporting containers, .NET Core in Linux will always work on all of those platforms. There's nothing special about .NET Core which makes it incompatible with anything else. So if you want to run it on Fargate, if you want to run it on ECS, if you want it on Kubernetes, if you want to run it on any other company's Docker container system, a .NET Core Linux container will work there. If you're running .NET Windows containers, those containers will only be able to run on hosts on Windows servers. And so that means that you need to be using, for .NET Windows containers, you need to be using a service which supports .NET Windows containers, or physical Windows Docker containers. So they're a completely sort of different thing. You've got Linux containers over in Docker world, which is the common Docker, the Docker sort of Linux thing. That's what everyone, when they call about Docker, that's what they're talking about when they talk about containers. And then you've got Docker containers for Windows, which is a different thing. It works in a slightly different way, and it's slightly less mature. And so, generally speaking, it's possibly a little bit harder sometimes to actually build .NET Windows containers. And also, I mentioned before that a lot of the actual, the base layers, those base layers are effectively Windows. And so they're very heavy and they're very large. 7 gig files, it's not uncommon. So when you're doing common sort of Docker things like do a Docker pull or taking a base image, it can take somewhere up to 15 minutes. Whereas a Linux equivalent of taking a Docker pull on a Linux image will only take a matter of seconds. And so it can affect the kind of the workflow a little bit. So you can build two different types of container, one for Windows and one for Linux. It's worth mentioning as well, .NET Core can also run on Windows as well. So you can build .NET Core on Windows as well, just to confuse things and make it a little bit more complicated. And again, that's a case of compatibility. I've certainly built .NET Core applications, especially in 2.1, that only work on Windows because they use certain Windows-based features, and I can't port them to the Linux version of .NET Core without getting alternative DLL, getting into a world of mono, basically. So the base layers for these containers, there's really 4 that are commonly used. We have a thing called Windows Server Core, a thing called Nano Server, a thing called Windows and a thing called Windows IoT Core. And these are base images, and these base images are maintained by Microsoft and can be used inside of your Docker files. Generally speaking, if you're using Windows Server Core, then that's going to be for more traditional .NET applications. If you're building a 4.2 application or a ASP.NET 2.0 application, it's going to have to be using a Windows Server Core base image. Occasionally you'll find things which you need support for, but they're not in that image. Then you might have to drop back into a Windows-based image. A Windows-based image is massive because it's Windows. It's got everything that Windows has, but it's really compatible. It has literally everything, so it's as if you were running it almost on the server. So it has the full set of Windows APIs. So there's some types of applications which just require certain Windows APIs, and you can't patch them or do anything with them, so you have to use those base layers. If you're building .NET Core applications, then there's an image called NanoServer, which is possibly what you'll be using, and it's like a cut-down version of Windows. It doesn't have some of the UI elements and some of the features which in Windows Server, and probably are not going to be used by your application. But it's a Svelte container, so it's a nicer base image which you can use. And then we have Windows IoT Core, which is the basis for many IoT sort of Windows projects which use containers. So you probably, if you're building .NET applications, ASP.NET applications, or and you're not in the IoT space, you're probably not going to use the Windows IoT Core world. So generally speaking, most images that you'll be using are Windows Server Core or NanoServer. And then inside of those, there's lots of different flavors of base image, which have been designed for different kinds of workloads and different things. So there's like a Windows Server Core for ASP.NET. There's a Windows Server Core for WCF. There's a runtime. There's an SDK version. Maybe you need it in your build containers. There's lots of different types and different flavors that you'll need. So the basics rule is you want to try and use the very smallest base layer that you possibly can in your container, because you want to keep your containers as small as possible. And basically you want to use the lowest or the smallest version of Windows until you hit a point where you've got an API which isn't supported, and then you could use a different base layer. There's also the NanoServer, which have been pre-pitted with different versions of .NET Core. And they basically maintain these are all Docker containers effectively. These are custom Docker containers built by Microsoft, and then they host them in their own Microsoft kind of Docker registry, Docker compliant registry, where you can download them. And that's what that mcr.microsoft.com thing is. That's their version of Docker Hub. It's the Microsoft sort of container registry. So you can literally just take that and plug that into the top of your from statement inside of your Docker container, and that would be your base image for your container. So let's create a .NET Core container. Cool. So over in Visual Studio, we're going to create a web project. And we're going to see an ASP.NET Core web application. Click Next. We're going to give this name Customer Front End. Create. We're going to untick configure for HTTPS, and we're going to disable or enable Docker support as well in here. We're going to add it manually in a moment. I'm going to choose a web application, a Model View controller application. And then I'll go and create that file. Now it's just creating a base skeleton project for me. Now in this project, I'm going to right click, and I'm going to go inside, this is inside of Visual Studio, and I'm going to choose add Docker support to this application. And it's going to ask me what version do I want to choose, Linux or Windows, because this is a .NET Core application, it could run on both. It will then create a Docker file for me in the base of the application. That feature, all it did really was create that file. And here we have our file, which is basically a multi-stage build Docker image. And as soon as it loads up, you'll notice at the bottom there, it's starting to build that container already. It's starting to pull in all the basic base images that it needs. And we can basically, inside of Visual Studio, press play or press F5, and we could run it inside of a Docker container. We can also, because it's now got this Docker image, and I'm using the AWS toolkit, I can now just publish that container to AWS. So I can say, this is my Docker repository, customer front end. I'm going to give this Docker container a tag, It might be latest. It could be, I could leave this blank, or it could be a Git commit ID, or whatever the way you tag your container images are. And then I can choose to put it on as a service on an EKS cluster, or what I'm going to do is just upload it to the Amazon Elastic Container Registry. So this is a bit like our version of Docker Hub. It's basically going to upload that. Now I've sped this up. It takes a little bit longer than this. It's quite a big image, but it ultimately pushes it over to the repository. Now what's cool about the integration we have in Visual Studio is that I don't need to set anything up in ECR. I didn't need to create a repository or anything. I just pressed the button and it did all that stuff under the hood. And now what I've got now is this URI, which is basically my base image. So I could do a from that, and that would be a Docker container, or I could see Docker pull and pull that image. I could do a Docker run and run that image, and my application now would run on my application as a container inside of a container. We have a nice little sort of UI inside of Visual Studio. This is the AWS team, the AWS toolkit for Visual Studio has built this, and it shows you like all the images that I have in that particular project, and I've got the tag latest on that particular container. But you'll commonly in a project have lots of different tags on lots of different types of image. You might have a dev, a test, a prod. My tags are actually the Git commit ID, because I'm not doing this in Visual Studio. I'm doing it part of a CI/CD project, so I'll be checking in my code, and then I would have something go and build my container in a CI/CD pipeline. And usually the thing that I would tag my container with would be the Git commit ID of what I committed. And that means that we can go back to, if I've got a container in production which isn't working right, I can actually go back to what the Git commit ID of that container is and figure out why it didn't work, or why I've broke the build. Yet again, mine. So we were building a Linux container there. You saw me building a Linux container on my machine. When I said we're building it, all of that support requires Docker to be running on the host machine. Now Docker on Windows has two modes. I can either be in Linux mode, Linux containers, or I can be in Windows containers mode. To switch it between the two, I need to just go to the bottom of my screen, click on the whale, and choose switch to Windows containers. It gives me a warning about switching to Windows containers, and it takes about 30-40 seconds, and it's switched to Windows containers. And what this means now is I could build Windows containers, Windows-based images, if I wanted to. So now I can create a .NET container image, and we'll do a similar thing. I've got a standard, this isn't that old, it's a 4.7 .NET API. And you can see the Docker image is much more straightforward. I've got a from base image, I take the source, create a working directory, and then I copy the my compiled application into inetpub on that image. Now if I press the Docker play button here, it would go and create this image for me. But I'll just show you what it's actually going to be doing behind the scenes. If I open up that folder and then type cmd into that folder, it will open the command line at that folder. That's a trick that you might not know about Windows. If I just paste this in Docker build, and I basically pass in the output of my built project, and I'm also going to tag this image as full fat latest, and then I've passed in some other things which are required for the build, and we're basically going to create a build image from that. So it's going to look at that Docker file in that folder which I'm in, and when it's going to go and build, it's going to take the project files and it's going to construct my Docker image. So you'll see that there's a number of steps. Basically, each of those steps is it opening and creating that layer. So the first thing it does is goes and takes the base image, then it copies to inetpub, and then it copies my output, my basically compiled application into inetpub. And then finally it tags the image as the Beebs full fat latest, which is the name of my image. So I can then just go and say Docker push, and push that image, the Beebs full fat latest. And you'll see, because by default I'm using Docker Hub, I just gave the Beebs full fat and it knew that I was using Docker Hub, so it's going to actually publish that to Docker Hub, so take that off my laptop and put it to the Docker container registry. And it's pushing each individual layer, and the cool thing about that is that if parts of the layers don't change between builds and pushes, it will only upload the portions that have been changed. So it's not going to be uploading every single time the base image, for example. but gradually it's going to go and push that over to Docker. And so that's basically two kind of different .NET projects. I'm effectively adding a Docker file with a different Docker instructions, and we ultimately end up with a Docker container, or a built Docker container, which I then put into Amazon Elastic Container Registry, which was what I did on the first instance, or I put it into Docker Hub, which is what I did in the second instance. So Amazon ECR, the Elastic Container Registry, is a fully managed Docker compliant registry. It means you can store Docker images. And the reason you might use this is because ECR is private to you. And so it means that any containers that you're building are only available to the people that you provide security credentials to. So whereas Docker Hub, Docker has private repositories and so forth, but Docker's very, very popular. Docker Hub's very, very popular with open source containers which you want to share publicly, because it makes it very, very easy to share those containers. Everything, when I just push that Docker, the Beebs full fat, that's a container that any one of you could go to my Docker Hub repository and pull down yourself and start using if you wanted to. So Amazon ECR is kind of like a private version of Docker Hub, and in more sort of enterprise settings, you probably want to be using a private container registry. It's fully managed, it's highly available, and it's obviously secure. And it's Docker compliant, so all of the commands work the same. However, it's slightly different in terms of the way you log into it, and it's a little bit more tricky to use. And let's go and show you how that works at the command level. So I've already done it through Visual Studio. I've kind of built my Docker container in Visual Studio, and then it did a lot of stuff for me to take that container and put it into ECR. But if I want to do that command line, this is kind of how I would do it. So I actually have to go to the ECR service. I could do this from command line too, but I'm going to just use the console to do it because I'm a GUI kind of person. I like to click buttons. And I create a repository. I'm going to call this repository front end. Oh no, I'm not. Full fat. Sorry. You can, there's options when you push a thing to this repository. You can scan the container image for sort of known vulnerabilities and that sort of thing. That's part of the ECR project. And then once I've created the repository, it gives me on Mac and OS Linux some command line things I can run to sort of to tag my Docker images, my local Docker images, and push them to ECR. So there's Mac OS and then there's Windows commands. The Windows commands are in PowerShell. I actually find it much easier with Docker. I really like PowerShell, but I find it much easier with Docker just to use the Docker commands on Windows, these ones on Windows as well. They all work on Windows, so it's fine. The first bit, which it tells you to do this line, which says AWS ECR get login, no include email, region West EU West 1. What that does is when you run that, it will echo a Docker command that you then have to go and execute, and that will log you in to your ECR. So you have to be inside of you have to be a command line with AWS, the AWS CLI, and then you run that command. It will output a command that you then run, and then that logs you into your ECR cluster, registry, sorry. I then can build my image. So if I'm inside of a folder which has got the project already in it, I can say Docker build, and then it basically would go and build the project based upon the Docker file. If I've already got an image though, I could just tag that image to be the tag that I need to go and upload it to ECR. Tags are really important in Docker. Images are basically these sort of objects which contain all of these different layers, but they can have different tags. The same exact image can have completely different tags, and most of the registries use these tags to decide what the image is. So I actually have to tag my image. You see on step 3 there, Docker tag, I want to take my local container called full fat latest, and I want to tag it with this long string, which is basically the name for the container in the ECR registry. So it's basically taking one container and just calling it something else. And then once I've called it something else, then I say Docker push and give it the long name. And because it's got the sort of AWS, Amazon, Docker knows that that's not going to try and push it to Docker Hub, it's going to try and push it to the ECR repository. And as long as you're logged in at command line, that's going to work and upload. If you're not logged in, if you haven't run the first command, for example, then you're going to get security errors and it's going to say you can't push to that repository. So we're going to tag our image. So I'm just going to look at the images on my machine. I'm going to then tag one of those images and I'm going to push it to ECR. So Docker images. See, I've got the Beebs full fat locally. I'm going to take the image ID. So tag that image ID. I could use the image repository as the name on the first column as well if I wanted to, but I like to use the image ID. And then I'm going to tag that with the name of the ECR repository. And now I have locally 2. Now it's the same image. If you look at the image ID, it's exactly the same image, but it's now tagged as 2 different things. On my file system, there's actually 1 image, and it's called 2 different things. But that means now that I can push that to ECR. So to push the image, I basically do docker push, but what I need to do first is to log in. So to log in, I take that command, which was shown before, AWS ECR get login, no include email, region west 1. It echoes a Docker command. I copy that Docker command. So it's Docker login. And then I paste it in my command line. Boom, and now my command line's logged in to that ECR. So now I can push that image and to my repository. So I can say Docker push that image to there, and it knows where to hook it up, and it starts pushing my image over to ECR. So now in ECR, it's starting receiving that image, and it's storing it in my repository. So if I go over to my repository there and click refresh, boom, I've got a new container image in my repository, which is cool. And that's my image URL, and I can share that with anyone on my team. I could use that as the ECR also has an eventing system. So anytime you push an image, you can event things to happen. So you can event a CI/CD pipeline to start building. You can event a scan of the container image. You can do all sorts of things. So if you want to automate your workflow, all of this stuff is possible. If you delete an image, you can set an event as well, and maybe raise a ticket with your operations team as why someone deleted the most important image, which is required for production, for example. You could do those sorts of workflows with it. So now if I want to take that image and push it to Docker Hub, well, it's very similar, but I don't have to have quite the complicated login procedure. So again, I've got my Docker images locally. I'll go and take this image. Tag that image as something else. I could use latest. I could not include a tag at all on it, or I could just arbitrarily put a tag 234. Like whatever I want to put as a tag there could be whatever. Now I have multiple images. So if I were to go and do a Docker push and push this now, I'll get an error that are denied. And the reason it is because I logged into ECR. So I'm going to log back into Docker. And with Docker login, it's just a username and password. You don't need that complicated, sort of like more complicated certificate. And now I can do a Docker push, and it pushes it over to Docker, is that image. So now on that container, I have latest, and I also have at the bottom there, which for some reason, there we go, I have another version of that image as well. So these tagging of images is really common in workflows. You might tag a GitHub ID as your container name, and then as it moves through the production cycle, move from dev to test, you might relabel it, and then finally that it will be changed to a production version. That's a really common workflow. So you actually don't change the image, you just retag them as different things, and those different tags start up different processes in the CI/CD pipeline. Now you've got your images in either Docker Hub or ECR or whatever container registry that you have. You can even host your own if you want to. I don't know why you want to. You then have an option as to how you want to run them in AWS. Do you want to use ECS or do you want to use EKS? So ECS has been around longer at Amazon. We've been building it for a long time. We've got customers which are using it at huge scale. It's extraordinarily battle hardened. You can be confident that if you're running containers in ECS, it's definitely going to be totally fine. It's going to be, we've got all of our biggest customers which use containers are using many of them are using, ECS. And then we also have EKS, which is an open source system, originally came from Google. It was open sourced, and we have a managed service for EKS. And we have some customers doing massive scale on EKS as well. So the choice never is which one scales better, because they both scale pretty well, in my opinion. For most kinds of workloads, you'll be fine. Generally speaking, though, it's kind of, well, which platform do you prefer? Do you prefer EKS or do you prefer ECS? Do you have any experience in either one or the other? But fundamentally, they do similar things. So you can run .NET Core on Linux containers on both platforms. You can run .NET Core on Windows containers on both platforms. And now you can run .NET Framework full Windows containers on both platforms as well. So we've added very recently Windows support to EKS as well. So Windows nodes to EKS. So basically, they can do very similar things now. You can run Linux containers on both of them. You can run Windows containers on both of them. They've got very different ways of orchestrating them, and the file systems are very different, but fundamentally they do the same job. Now we're going to be talking about EKS for the remainder of this talk. So what do we do now? We've got our containers. How do we start using them on EKS? The Elastic Kubernetes Service, or Amazon EKS, is a fully managed Kubernetes control plane. Kubernetes is a Greek word. My old boss was Greek, and he used to call it Kubernetes. And I used to make fun of him because I was like, it's not Kubernetes, it's Kubernetes. And he said, it's actually a word in Greek, you idiot. So, so he was right. But I think it's nautical as well. I believe it's like it's like the thing of the steering wheel of a ship. I don't know. But Kubernetes is nautical. Everything in containers is nautical. Docker, whales, Helm it's all nautical themed. I'm not quite sure why. Anyway, Kubernetes is this is our managed platform. You create a cluster in Kubernetes, and then on that cluster you start running your containers. When I say you create a cluster, you'll create a cluster of effectively EC2 instances. These are the worker nodes that's going to run your application, or where your containers are actually going to physically live. And then we have a managed control plane, which manages the orchestration on those worker nodes. So the way that you interact with the cluster is through command line generally, and you can sort of send instructions to your cluster on how to build your application. You can run one application on a cluster. You can run multiple applications on a cluster. And many customers will have a single Kubernetes cluster and then run all of their different workloads and different types of applications on those clusters. If you're building on AWS's EKS, it's possibly it's a really good idea to download this tool called EKS CTL, which helps you with the command line aspect of building clusters. It makes it simpler, and especially if you're going to try using Windows nodes on EKS, definitely download this, because I tried without it, and I spent about 2 days getting Windows nodes working, and then when I actually just used this one to build the Windows nodes, it took me literally 10 minutes. So there's tons of clever work that they've done in this to make your life easier. So EKS CTL is a tool that you want to download and you want to use, and all of the examples that I'll show in this talk use this particular command line. So we're going to create an Amazon EKS cluster using that tool. Now the first thing we're going to run is this command, EKS create cluster. We're going to give the name Windows cluster. We're going to use the version of Kubernetes 1.14. It's going to create a node group with standard workers, and the node type it's going to be using is t3.medium instances. It's going to create 2 nodes with a maximum of 3 nodes, and it's going to use the Amazon machine image, or it's going to use the best one it thinks it's got. And I'm creating this one in US East 2. Now that usually takes 15 minutes, but this is a video, so it took about 13 seconds, which is good. But your reality will differ from this. When you run and execute that command, I went and got lunch today to do that. This is cool because you're only ever going to build a cluster once. Well, it's going to be a rare event, but it will take about 15 minutes to build a cluster. So that one command is built as a cluster and a sort of control plane. Once you get that bit at the bottom, it's like a tick which says the demo Windows cluster is ready. You're then able to start interacting with that cluster. So I'm going to do 2 things. I'm going to install these things called VPC Controllers. I'm going to be installing Windows nodes on my cluster. Usually in a Kubernetes cluster, you have just Linux nodes running Linux containers. But because I want to run Windows containers as well, I'm going to run a mixed cluster. Some of my machines are going to be Linux, some of them are going to be Windows. And basically, when I create a container, I'm going to say which version of Windows, should it go on Windows or should it go on Linux? I'm going to define that in my thing. So Kubernetes, when it's looking through my definition for my application, it's going to look at the container and it's going to go, oh, this container needs to go on a Windows machine, so I'm going to put that over on Windows. Or this one needs to go on Linux, I'm going to put it on Linux. So you can have multiple nodes of different operating systems inside of a Kubernetes cluster. So this VPC controller, what it's doing is it's setting up the networking so that Linux and Windows can talk to each other. Again, this is actually, all the rest of it, creating a cluster is really simple, but this piece is a one line in this tool. It actually is a few lines if you want to do without a tool. So I would just run EKS utils, install VPC controllers on that particular cluster, and it will go ahead and it will build them. That actually is real time. It's very, very quick what it's doing. It sets up the networking which is required to run those worker nodes. Now I actually need to go and build some actual worker nodes to run. So I've got some Linux nodes already set up which are running the base system of what I need. It's got some stuff which is operating on some of the Linux nodes. Whenever you're building a Windows, even if you're only using Windows containers, you do still need at least one Linux node on your cluster. For the networking stuff to work. And that's what I've just done there, is installed it on that one single cluster that we've got, one single node, sorry, that Linux node. And now I'm going to add the Windows nodes to my cluster. To know which node to Windows machine to run, I go to this website, and it's got the EKS optimized Windows Amazon machine images names. So it's going to give you like an ID for the army based upon the region that you're going to build your cluster in. So I'm building it in sort of US East 2. So I'll go and view IAM ID, copy and paste that, and I paste it into this command, which is creating a node group. I'm going to call it demo Windows cluster, and it's going to be basically creating 3 nodes, T3 mediums, and they're going to be using Windows Server 2019 full containers, and I've passed in the AMI for that image. So now what I should have is a cluster, an EKS cluster, which has got some Linux nodes in it and some Windows nodes, so I can start deploying an application to it. So if you go to the Microsoft .NET Framework samples, they have some images, base images for lots of different project types. So you can see this Docker pull ASP.NET app. If you run that Docker command on your local Docker machine, it will download that Docker container and run it. So I want to take that Docker container and I'm going to add it to a Kubernetes YAML file, which is all it's got in it is a deployment, it's got a name, Windows app, and then it's got a container specification. So I'm going to add that particular Docker container as my container specification. I'm going to open up port 80 on that container. And then I'm going to do this. This is really important. I'm going to say that container has to run on Windows. That container can't run on a Linux node. It has to run on a Windows. It has to run on a Windows node, not a Linux node. And then I'm going to create a service, and it's going to listen on port 80. And it's basically a load balancer. And that load balancer is going to select the Windows app, which is basically this application container. And it's anything which comes into that load balancer, it's going to forward on to that container. So basically what I've created is an endpoint for my application. Port 80 endpoint, and it's physically, when I deploy this to Kubernetes, Amazon's going to create a load balancer for me based upon that description. It's going to create a container, a single container at the moment, and it's going to map them together. So whenever I go in on the load balancer, it's going to go into the particular application. And that application is going to be running that sample container. So I've got this image, the Beebs full fat, over on Docker Hub. So I'm going to actually replace that, that Microsoft sample image and replace it with this one. So if I want to change the Docker image, which this application is using, all I have to do is replace that Docker image with my container image, and now all of a sudden it's going to be running my container. It's no longer going to be running someone else's. And so if you wanted to deploy a new container, generally what you'd be doing is you pass in a new container, or more likely a container with a new tag, and then deploy that by saying Kubernetes kubectl apply, and apply that Windows file. And basically what's happened in Kubernetes in the cluster, it's deployed the Windows app and it's deployed the app service. And because I made a modification to the Windows app by changing the container, it's come back and said, you've configured the Windows app and you've the actual load balancer has been unchanged. I generally work with Kubernetes in this way, is that I have one big YAML file which describes my entire application, and then I apply it all as one. You don't actually need to do that. You can apply them as separate services, but I quite like the idea of having my whole application defined in one single file and then applying that whole file, knowing that Kubernetes will only change the things that I've changed. So it will look through all of the different services inside of my application. It will deploy load balancers, deploy containers, but only things that I've changed will get actually deployed or changed. So I changed the Docker image that it's using. So it's sent that to the Kubernetes cluster, and the Kubernetes cluster is now going to start building with that new container image. So if I go kubectl and say get pods, so this is in my cluster, get all the pods in my cluster, you can see that I've got one pod now which has been created. Now that definition, that deployment is created one single pod. And you can see it's a status of container creating. And if I say kubectl describe pods and then pass in the actual pod name, it will give me information about that pod. So I can see the container ID that it's using, the container image that it's using, and also it gives me some log information about what it's doing. So it's successfully assigned it to a node, and now currently it's pulling the image. It's a big image, so it's going to take a little bit of time. After some time, I'll run get pods, and eventually I'll get this back. It will say that pod is ready, one of one's ready. So I've got one single container running in a pod, and now if I wanted to scale that up, I could do that. Oh, I just want to mention one thing. Now I've got that one pod and I've got my load balancer, I could actually go and see that thing. So if I open up the load balancer, there's a thing in Kubernetes which I say is kubecontrol get services, and it lists all of the services inside of my cluster. One of those services is going to be a load balancer, and you'll see it's got an internal IP and it's got an external IP as well. That's an external application load balancer in AWS. If I copy and paste that, and then paste it into a browser, that load balancer is listing on port 80. It's going to forward it to that particular container. There's my container image in Kubernetes. I could have multiple containers running and change where my load balancer is pointing to at will, apply that change, and all of a sudden my load balancer will switch to different containers. So I can switch containers in and out really quickly. You can do blue-green deployments, you can do more complicated workflows and so forth. I've only got one of those containers. I might want to scale that. If I just go into that file and just change the number of replicas from 1 to 3, and then save that, then go into command and say, let's run the exact same command, which is apply windows.yaml, that file. It will change my Windows app, that's changed, but it's not changed the service because I didn't make any modifications to my load balancer. And now, if I do kubectl get pods, instead of having one pod, I'll have 3. Well, I've got 1 actually, which is running, and I've got 2, which are being created. And I could inspect each of those containers. I can go into each of those pods and look at the container image. I can get the logs for that container image. I can even go inside it and start executing commands directly inside of the container as well. If it's a bash, or if it's a Windows, I could go in there and start executing PowerShell. So you can explore those containers. You can find out what's going on if they're not working or not running properly. These obviously are creating or they're pulling their images. Eventually, I'll end up with 3. And what will happen is my load balancing service now will just load balance across those 3 replicas. So if one of them fails for whatever reason, then the other 2 will change. Now, if for whatever reason in the system, someone kills one of those containers or deletes or removes the container or it crashes or whatever, Kubernetes knows that there needs to be 3. So it will just create another one. and replace it. And that's the power of Kubernetes. Like, once you define your infrastructure and your application, it's then Kubernetes' job to make sure that's what it builds. So if you go and manually kill these containers, Kubernetes will start creating them again. And so if I have 3 of these containers running, I can pretty much guarantee that those containers, especially if they're distributed on a cluster and they're deployed on different machines, even if that whole node fell down, there would still be some containers running somewhere in my cluster. So it's a really great way of building resiliency, especially if you've got a large enough cluster with enough nodes, then you're starting to build real resiliency inside of your applications. And so containers can fail and stop and start. It doesn't matter. Kubernetes will restart them and make sure that your application gets back to the position that you've defined inside of your YAML file. You don't have to use YAML, by the way. You could use JSON if you're crazy. You could also just execute it at CLI level as well. You could run commands directly in the CLI and create services and that sort of thing as well. Again, I wouldn't do that, but I'm sure people do. Now, if I wanted to create a little bit more of a complicated application, there's a PDF system which I built actually in my old business, in my old company about 10 years ago. It's still running at a major company in the UK, and it does a really simple thing. And I was recently speaking to them about it because they were trying to convert it to .NET Core. And the problem was the back-end service, it basically has this thing which takes a PDF file and it uses system.drawing to do some random stuff with this PDF file. And it's really powerful, and it's a really useful thing for this company to be able to modify and basically look. It basically takes a PDF file and it reads the PDF file and converts it to text. It's like an OCR engine. They've built it, it's really powerful for what they do, it works really well. They don't want to have to redevelop it. So they were wanting to try and containerize this application because it's just sitting in virtual machines. And so they looked at, well, this is roughly how their application works. So they have a load balancer, and that calls into a front-end website where customers upload the PDF, and then the front-end website takes the PDF that's been uploaded and it forwards it to the .NET, the full-fat .NET legacy application, which then processes it and then puts that information into a SQL database. Now, when they started, they wanted to containerize their SQL database. I'd always advise against containerizing your databases. They instead used SQL database RDS, which is a database service. I would advise doing that if at all possible, like stop having to manage your own databases and start using a managed one. And so they then want to build this. So basically, I've got 4 pieces of infrastructure I need to create: a load balancer, a .NET Core front end running on Linux, a service, and then a .NET legacy application running on a Windows node in a Kubernetes cluster. So this is what my YAML file for that looks like. So I have, hey, there we go. I have a deployment with a Windows application and a sort of a name. It's called Windows app. What's also important here? And then it's got an image that's reading from my my ECR image, my container image. I'm not going to use Spotlight. And then it basically opens up port 80 on the bottom there. And what you'll see at the bottom there, it says that this particular image needs to be loaded onto a Windows node. So when it creates this container, it's going to run it on a Windows node. The next portion of that Windows.core application is the front-end .NET application. And it's almost identical. It's called something different. You'll see the app name is Windows-core-app. It's using a different image. That image is a .NET Core image, which I built from Visual Studio. That's listing on port 80 as well. And also I'm passing in at the bottom, if you can see it on line 55 at the bottom, I'm also passing in environmental variables. And this is a really useful thing. If you want to pass stuff into the containers, environmental variables is possibly the way you'll do it. And the thing that I'm passing in is the name of the service where my .NET application is going to live. And you'll see that I've called it api.default.svc.cluster.local. Basically, that means that when I create a service, I'm going to call it API, and that I know, because of the way that DNS works in Kubernetes, that that's what it will be called in DNS. So if any node inside of that cluster calls the DNS inside of Kubernetes with api.default.svc.cluster.local, it will go to a load balancer, which then directs it to the pod, which is running my Windows application. So these environmental variables are really useful to pass stuff in, database connection strings, the names of SSM parameters or secrets. I wouldn't obviously put usernames and passwords in these environmental variables, but definitely an SSM parameter, which you could then go and read inside of the application to get your secrets. That would be a great way of sort of piping in sort of information into these containers. And this particular container, you'll see at the bottom there on line 55, it says, on line 58, this has got to be deployed onto a Linux node because it's a Linux container. Then the next thing I do is I create two different services. One, the top one is a load balancer, and that points to my .NET Core application, my basic front end. And then the other service doesn't expose an external API. It's not a load balancer, it's just a service. That's going to be running basically it's going to be running inside the cluster. And what that's going to generate for me is a service which has got a DNS entry in the cluster that I can call. So my application, if I want to call the other application, just uses that local DNS and can call that other application. Does that make sense? So because the API has got the name, if you see the service on line 80, I've given the name API. If I change that name to API Jeff, then my DNS entry would be apijeff.default.svc.cluster.local. Default there is the namespace that I've put it in. If you don't apply a namespace, it will go into the default namespace. Cool. And then this is my application. I upload a PDF, upload the image, and it forwards it to the correct the other application, which then goes off and processes it in a really sort of basic way. So that's the way we sort of build networking between applications and different containers it's effectively using DNS. The cool thing is this company realized that they could move away from actually using their pre-built container and start using a service called Textract, which allows them to do OCR on PDF forms. And they actually were able to create an API in .NET Core. Now we're sitting in a situation where they've got basically all their containers are .NET Core running on Linux, and they still have a load balancer and a service. But now, because it's running all on .NET Core, we can start doing some interesting things. We could run them in Fargate. You see with ECS, I had to go ECS, and with EKS, I had to create nodes, places where stuff lives. Fargate is a container service where you don't have to create the nodes. Now, Fargate only runs Linux nodes. So if you want to deploy Windows applications, you can't do it on Fargate. That's why they actually have to refactor the Windows portion out of this if they want to run it on Fargate. But now they could take this application and they could run it on Fargate. Now, if you want to run it on Fargate, you could run that on ECS. There's a Fargate for ECS. Or as of today, there is also Fargate for EKS, which means instead of creating the nodes, you basically can create a cluster, and that cluster is of type Fargate, and then basically when you create your containers and so forth, it will deploy, as it's deploying your Kubernetes application, it will start deploying nodes, effectively manage nodes for you using Fargate. So you don't have to create or manage the infrastructure or the worker nodes yourself. They're going to be created and provisioned for you as you deploy your containers. So I'm just going to quickly show you a blog where you can read a little bit more about this. It's written by an incredible author. His name is my name, Martin Beebe, on Jeff Barr's blog, and it's basically talks to you about how you would set this up for EKS on Fargate. And this is only available if you want to use .NET Core applications which can run on Linux. You can't build Windows applications using this. But everything, I don't actually mention .NET or Windows here, but rest assured, if you want to build this using .NET Core for Linux, you could absolutely do this. And it's very straightforward. Again, you're using this EKS CTL to create your cluster. The difference is you pass this parameter in saying Fargate, and it creates a cluster which basically, as you start deploying your Kubernetes applications to it, it's going to start spinning up infrastructure for you without you having to create any worker nodes. So this basically provides a whole demo about how this works. It's very straightforward, and it's live in everywhere which supports EKS as of today. All I will need to say is thank you very much for listening. I've overrun by 3 minutes. I've not had much luck with this switcher. There we go. Thank you very much for listening. Please do feedback in the application. Rate this session. I'm at the Beebs on Twitter. All of the links and so forth that I've done, I'll tweet after this session. If you're on Twitter, please do go there. If you really liked this session and you thought it was really good and valuable, please tweet me at the Beebs. If you hated it, if you think I've wasted your time, then please come and speak to me after. Thank you very much indeed.